everybody has had a good day today? All right, students, welcome back to Human Anatomy. All right, now, students, we have finished with our central nervous system chapter, and we have begun chapter 10, special senses. We're finished with the eye. Now we're working on the ear. Okay, now remember we have 5 senses for vision, hearing, taste, smell, and touch. So we've still got 3 to go, but today we're going to concentrate on the ear. So I want you to remind you of your course syllabus that you have for the ear, okay? We're going to discuss the functions of the ear. Okay, hold on just a minute, kids. Let me put this on the document camera. Okay. All right, now we have 2 objectives that are in your course syllabus: identifying the parts of the ear and describing their function, and tracing the pathway of sound from the pinna, the outer ear, to the temporal lobe. Okay, so those are going to be our 2 objectives today. So we're going to get started on that. On the ear model, we're going to start with the ear model. Now, students, we have a complete diagram of the ear model in your course syllabus, so be sure that you reference that. All right, now, students, let's go ahead and get started with our ear model. And so by the time we finish this, you're going to be an expert on the ear. Okay, here's our ear model. Okay, let me turn it this direction so you can see it better. Okay, well, let's discuss the outer ear first. Your ear is in 3 segments: your outer ear, your middle ear, and your inner ear. So right now we're going to discuss the outer ear. The outer ear is the part that you can actually see. Okay, this is the pinna, P-I-N-N-A. The top part of the ear is called the auricle. Okay, now as air flows in to produce sound, it's going to travel to the auditory canal, and this is where you have your earwax, or what we call scientifically cerumen. Okay, so it settles into the auditory canal. This is the outer ear. As sound pushes through, it's going to touch the eardrum, and the eardrum, the other name for the eardrum is the tympanic membrane. Okay, now this is a landmark that's going to separate the outer ear from the middle ear. And as soon as air flows to the eardrum, it's going to hit the eustachian tube. Okay, now unique function of the eustachian tube, children, this is connected to the back of your throat. Okay, so that has a big significance, because when you reach high altitudes, like if you're in an airplane and you reach a certain altitude, or you're driving up a mountain, what you're going to soon find is that your ears are going to begin to get full or begin to pop. And so they'll have that popping sensation, or that roaring. And what that is your eustachian tube is trying to meet the need of the pressure that's being forced in from the outside atmosphere. So what it's doing, it's accommodating what's going on inside your ear. So the best way to take care of that is simply to swallow several times, and that will open up your eustachian tube. Okay? Next, we're going to get to the middle of the ear, kids, and this is the 3 bones, or the 3 ear ossicles. You have 3. You have the hammer, which is the malleus, the anvil, that's the incus, and the stirrups, that's the stapes. So you have scientific names for all 3 bones, okay? That constitutes the middle ear. Now, when sound comes from the outer ear, pushes in through the outer ear to the middle ear, it's going to cause a huge vibration. And what it does, it's going to push sound to the inner ear. Now, it has to reach the stirrup, the last bone. So when the stirrup starts to vibrate, all of the sound waves go to the inner ear. Okay, and this is the inner ear. Okay, this pops out. So let me explain it to you. The semicircular canals are part of the inner ear. Now, students, this doesn't have a lot to do with hearing, but has everything to do with balance. Now, remember in your central nervous system chapter, we talked about how the cerebellum at the back of the brain actually helps keep you upright and balanced. Well, this is the inner ear part that does that. So when you turn your head to the left or to the right, your head and your ears are actually accommodating the movement. And the reason why is the semicircular canals right here, okay? So a sound wave passes through, it's going to hit the little small special organ of hearing called the cochlea. It looks like a snail. And deep inside of the cochlea is a duct filled with fluid. And the duct is filled with fluid of cells of the organ of Corti. And what that is, it's a very, very specific final receptor of sound. It's your true organ of sound. and it's going to push down, push out through the auditory nerve, and then it's going to hit your temporal lobe of your brain. Now remember, in the central nervous system chapter, we discussed that hearing is interpreted in the temporal lobe, right here, right above your ears, okay? And here's the cerebellum, and this is where your balance is interpreted. So it works closely with the semicircular canals inside of the inner ear, all right? All right, students, we're going to see a small film clip that's going to explain all of this in a little bit more detail, just in case anything was unclear.
The ear has three parts: the outer ear, or auricle, the middle ear, and the inner ear. The auricle, the visible part of the ear, collects sound waves and directs them to the auditory canal. The auditory, or ear canal, is lined with cilia and ceruminous glands. The earwax from the ceruminous gland and the cilia protect the ear from entry by foreign matter. The thin tympanic membrane separates the outer ear from the middle ear. Sound waves cause it to vibrate. The three tiny bones of the middle ear are the hammer, or malleus, anvil, or incus, and stapes, or stirrup. These bones pick up the vibrations from the tympanic membrane and transmit them to the inner ear. The eustachian tube of the middle ear opens into the pharynx and permits air pressure to equalize between the ear and the outside air. The inner ear is maze-like, consisting of bony and membranous structures surrounded by fluid. The semicircular canals are fluid-filled bony loops that help maintain our body's balance. The cochlea is a fluid-filled, snail-shaped structure that houses the organ of Corti, the true organ of hearing. The fluid aids in the transmission of the vibrations. The organ of Corti changes the vibrations into nerve impulses that are picked up by the auditory nerve. Sound waves are collected by the auricle, or outer ear, and sent to the auditory canal, tympanic membrane, ear bones, and then to the cochlea, where the vibrations are changed by the organ of Corti to nerve impulses and transmitted by the auditory or cochlear nerve to the temporal lobe of the brain for interpretation.
Okay, students, I hope that helped to a big extent. I know it's a lot of steps, but it's actually very simple once you put it all together. Okay, students, so let's go back over the steps just in case somebody's unclear. Okay? All right. Sound waves enter in to the pinna, or the outer ear. Sound then enters the auditory canal, which contains your earwax. The sound is then transferred to the tympanic membrane, or what we commonly call the eardrum. The three ear bones, or we call them the ossicles, the hammer, the anvil, and the stirrup, all vibrate. And then once the stirrup, the last bone, vibrates, it sends sound waves striking the cochlear duct deep in the inner ear. And then sound rushes to the organ of Corti deep within the cochlear duct. Now remember, the organ of Corti is the true receptor of hearing. So once the organ of Corti receives the sound waves, it automatically sends the impulses to the auditory nerve, and then finally to the temporal lobe of the brain for interpretation. Okay, so I'm hoping that's clear. All right? All right, students, there are several things that I have posted to your course, and we're going to need to have this done by Wednesday, 5 o'clock, so make sure that gets posted so that I can grade it. I have graded your pretest. You did great on it. It's been graded, and it's also posted if you haven't checked your board yet. This is a picture of the ear. You're going to need to complete this so that I'll know exactly that you know each part of the ear. Okay? And there are also 4 questions that we need to answer. All right, let's go over number 1. What is the scientific name for earwax? Number 2, why does the body continuously produce earwax? Number 3, what part of the ear separates the outer ear from the middle ear? Number 4, why do your ears become full and have a poppy sensation whenever you're reaching a high altitude? So students, those are the 4 questions that I want you to answer on your assignment, plus make sure that you fill out your diagram, make sure you do your labeling. Right? Okay, let's go over the organ systems of the ear one more time. Okay? That's going to help you with your labeling. All right? Okay, number one, the pinna, or the outer ear. The auricle is at the top. Number two is the auditory canal, where you have your earwax. Number three is your malleus, your incus, and your stapes, that are all bones of the middle ear. Okay. Number four are your semicircular canals that help you keep upright and balanced. Number five is your cochlea, which houses the organ of Corti. And then six is your eustachian tube in the middle ear that helps keep equilibrium even with the outside atmosphere. Okay? So I'm hoping all of that is clear, especially when you get ready to do your post-test next week. Okay? You did great on your pre-test. I expect you to do great on your post-test. All right? Okay. Now, students, for the remainder of the period, I have embedded a film clip called The Sense of Hearing. I want you to click on your video clip, but I want you to pause it after 5 minutes. Don't forget to use your closed caption option that's with your video clip. And we will go over this segment on our next class period. If there's any questions in the meantime, don't hesitate to post me anything that you need. All right, students, have a good evening, and I'll see you in the next class period.